processor. Performance analysis of a novel low complexity, high precision timing synchronization method for wireless sensor network. Let's we discuss about the project performance analysis of novel low complexity, high precision timing synchronization method for wireless sensor network. Abstract. Let's we discuss about the abstract. Due to the recent innovation in the area of the wireless technologies, it is feasible to deploy inexpensive, tiny, disposable, and low-power devices throughout the physical space for the measurement of physical environments like temperature, pressure, humidity, etc. These small devices are known as sensor nodes, and their deployment is termed as wireless sensor network. Sensor nodes have resources constrained in terms of storage capacity, battery power, and processing capabilities. Wireless sensor networks was originally developed for military applications, but later it has come for the public uses. Wireless sensor networks are useful for the military applications, medical applications, environmental monitoring, traffic control, industrial monitoring, etc. All the proposed applications of wireless sensor networks involves monitoring sensors, reading and communicating an event to other networks or sinks. The analysis made during data fusion or sensitive to the time at which an event occurred at each node. The application required partial or full-time synchronization. Therefore, it is important that the message exchanged by the sensor nodes for data fusion must be time-stamped by each sensor local clock. In this paper, we survey various time synchronization protocols and compare quantitative and qualitative various synchronization protocols. The performance of time synchronization is greatly influenced by various factors such as precision, complexity, and network size and energy conservation. The limited energy resources is the drawback of the wireless sensor network. Therefore, they save energy. The node's power consumption must be reduced. Data flow diagram. Let's we discuss about the data flow diagram. Network formation. Here, network formation means set the simulation area range and number of friends and nodes, and assign the each node's initial energy, transmission range, transmission range, receiving range, and simulation time. All are setting here. Synchronization method. Here we use low complexity synchronization method. Here low complexity and effective synchronization method that can be used in ultra low duty cycle synchronize MAC protocol with high synchronization precision. If check cycles means duty cycle. The interval time between each backup is slightly less than the entire beacon framework of synchronized node. The cycle deduction phase complete. The new node has successfully established synchronization with its parent node. That node record the time stamp and count the beacon. If that beacon is first, that node is active mode. Otherwise, the node is sleep mode. And then convert timestamp. The mathematical analysis. The proposed method. Before analyze and evaluate the synchronization method, we are using the several clock in the sensor node to measure the same time length, then the amount of the time measured by each node. So he convert the common time stamp to analyze mathematically. He analyze the each node latency and analyze the delay time for the each node. Performance analysis. Performance analysis means here analyze the output of the proposed system with compare the existing system to show the graph format. Here analyze the throughput, packet delivery ratio, and delay time and energy consumption. All are on existing system and a proposed system. Analyze to display the all output and performance are graph format. That graph format is used to compare the existing system and proposed system. Let's we discuss about the runtime procedure. Open the terminal window and then change the directory. Use the cd command. Type the cd and particular directory name and run the STCL file. Use the ns command and open the NAM window. NAM means network animator. Here all nodes are the form displayed in the tree format. This is the root node and grandparent, parent and child node. It is the reduce the energy consumption and overcome the delay time. Start the play button. Simulations are performed. The first here activate the root node and then activate the grandparent and parent and child node. All simultaneously use the time interval. Here we use the PAN and data transmitted to the 1 to 6. Here double quoted lines are the active nodes and yellow nodes is the go to the sleep node and grey color is the sleep node and black color is the other sleep node. Then green color is the child node. This is the parent node and grandparent node. Here we analyze the yellow color node go to sleep, that and grey color node is sleep node. The data transmission are performed here. Here we notify the traffic FTP traffic from node 1 to 6, which means 1 to 6 data was transferred. And here they are blinking, the blue and red color circles are intimated that data transmission are performed here. It is in this process used to increase the performance of the data transmission and overcome the delay time and energy efficiency. Here are data transmitter based on the scheduling concept duty cycle. Here we use the low complexity synchronization method and close the window. Run the graph file. Run the graph file. Use the GNU plat command and star that plat. Star means in here specify the all the plat files are running simultaneously. Here it is the latency graph. That is the latency. Here we get the latency value from the proposed output trace file. And then it is the packet last. Simulation time versus last state. Compared with the last state, existing system and proposed system. Proposed system reduce the last state of the packets. And then average delay time. How to overcome the average delay time in proposed system are displayed here. Average delay time is the y-axis and the number of connection versus the x-axis. Here to show. The red color line is the existing system and green color line is the proposed system. Packet delivery ratio. Number of packet delivered in the ratio format here, displayed ratio format, and then green color node is the proposed system and red color node line is the existing system. Here compared with the proposed and existing system, proposed system increase the packet delivery ratio. And simulation time versus throughput packets. Here increase the proposed system throughput packet. In this project we have objectives for increase the packet delivery ratio and reduce the delay time. The complexity synchronization method used to reduce the delay time. It is the low complexity. Compared to the traditional method, it's increase the packet delivery ratio and reduce the packet loss rate. Thank you.